Hi everyone, and welcome to our video on solving trig equations by factoring. So in the previous video, we had trinomials, or they're quadratic formed, where you have a squared term and then a non-squared term, and then it factors very similar to any trinomial that we've seen in the past. Here, we're still going to solve by factoring, but notice we've got different scenarios where they're not quadratics. Well, no matter what in these problems, we want one side to be 0. So on number 1, the very first step, so also let's say the second we see a higher power, we want one side to be 0. Okay, so higher power, and that really doesn't matter if it's trig or if it's something else. Higher power, we do want to make one side 0. Higher power, or even if there's multiple trig functions. Let's write that down below. Multiple trig functions, that's a different way to look at it. Still make one side 0. So number 2 is ready to go. It is set to 0. But number 1 is not. We want it to be set equal to 0, so we will subtract cosine of theta on both sides, or cosine of alpha. All right, and when we just subtract, notice the left side is a cube, so that means it stays as is. And then the minus cosine of alpha is to the side. And then I do have one side to 0 now. And then now we're looking to factor a lot of these. So if it's not a trinomial like the previous ones above, then it's usually factoring a greatest common factor. And so in this problem, we have cosine of alpha in common. So we would factor that out. So we're going to factor cosine of alpha out to the front. And it can help to even put that in parentheses. And then adjust the two terms after factoring out the GCF. So that means we have 2 cosine squared alpha left over in the first term, minus 1 left over in the second term. And then notice if you did double check with FOIL, so I'm just putting dots, cosine of alpha times 2 cosine squared is that one. And then cosine of alpha times -1 is negative cosine of alpha. So instantly double check with multiplying it back in. But now that we have one, we've factored it and one side is 0, we can set each factor equal to 0. So we have cosine of alpha equals 0, and we have 2 cosine squared alpha minus 1 is 0. Now the cosine of alpha equaling 0 is good to go. The other one, though, we need to continue solving. All right, so notice on this problem, we now have cosine squared alpha, but it is the only trig function in the equation that's left over that I'm concerned with. So that means I should isolate it. So then the first step is to add 1. So we have 2 cosine squared alpha equals 1. And then we'll divide by 2. So we have cosine squared alpha equals 1 over 2. And now I have a square that I need to get rid of. Well, to get rid of it, we would square root. Now remember, if you square root, you always include plus or minus. And when we do that square rooting a square cancels those out. So I have cosine of alpha equals, and then I do have plus or minus the square root of 1/2. So here's my little scratch work. That is the same thing as the square root of 1 over the square root of 2. Square root of 1 is 1. Square root of 2 is still square root of 2, but if we rationalize it, then we would have square root of 2 over 2. Okay, so we would have plus or minus square root of 2 over 2. Chances are these are values that we would recognize from the unit circle. If they are not, then maybe we did something wrong, or look in the question to see if they want you to round, which would be a hint that we need to use a calculator. Okay, however, most of the time they try to make these to where they're on the unit circle. All right, so now that I've got these 2 cosine alphas ready, I'm going to do this one in blue, where cosine of alpha is 0, so it's saying find the x coordinates that are 0. Well, that's up there and down there. So that's at pi halves and 3 pi halves. And then in the purple, cosine of alpha equaling plus or minus the square root of 2 over 2. Again, that's an x coordinate where I have either positive or negative square root of 2 over 2. Well, that's in the middle of every quadrant. So it's all of the ones that have 4 in the denominator. So pi quarters, 3 pi quarters, 5 pi quarters, 7 pi quarters. And there we go. There's all of our answers from 0 to 2 pi. And then we would just add the 2 pi k to them for a final answer. So for our final answer, we would have alpha is equal to pi quarters plus 2 pi k, pi halves. Oops, I wrote the 2 up top. Let me fix that. Pi halves plus 2 pi k, 3 pi quarters plus 2 pi k, 5 pi quarters plus 2 pi k, 3 pi halves plus 2 pi k, and then 7 pi quarters plus 2 pi k. There they all are. Okay, so we've got all of our angles for this problem. All right, so that's a special factoring. Now let's look at number 2. So number 2, it is set up to where I have one side 0 already, and then I see a bunch of trig functions. Well, what's going to happen here is I would want to factor the cosine of x from both sides. So we see, oh, there's something in common. So kind of similar to the last problem. So we would take the cosine of x out, and then we're left with, well, if you take a cosine of x out of cosine of x, you get 1 plus 2 sine of x is left over there. And then remember, this still double check. Cosine of x times 1 is cosine of x. Cosine of x times positive 2 sine of x is positive 2 cosine x sine x. So everything is a match. And then now we can set each factor equal to 0. So cosine of x equals 0, and 1 plus 2 sine of x is equal to 0. Now the cosine of x equals 0, again, is ready to go. The sine x1, I should subtract 1 over. So I'd have 2 sine of x equals negative 1. And then I could divide by 2. So I have sine of x is negative 1/2. And then now I'm using the unit circle. And I'm going to color code the cosine of x equaling 0. Well, we did just do that. It's up here at pi halves, and it's down here at 3 pi halves. And then where sine of x equals negative 1/2, sine of x equals negative 1/2 is in quadrant 3 and quadrant 4, close to the x-axis, with meaning we would have 6 in our denominators for the radian measure. So 7 pi over 6 and 11 pi over 6. So those are our 4 answers, this time between 0 and 2 pi. And we just make sure to add 2 pi k to them for official final answers. So we would have pi halves plus 2 pi k, 7 pi 6 plus 2 pi k, 3 pi halves plus 2 pi k, and 11 pi 6th plus 2 pi k. And done. And like always, we can double check. We can plug some of those back into the original equation to verify. But these will work out. They you could double check for me if you want, but yeah, they're going to work. Okay, so that's what happens if we have higher power trig functions or multiple trig functions we would want to factor. All right, thank you for watching. If you have any questions, please let me know.